A journey through the universe. Real perception. So far, we've only just begun to understand space, like traveling just a day's distance. Slowly rising, we first reached the closest celestial body, the Moon. Dozens of astronauts have visited it, walked on its surface, and left their mark. It's just 400,000 kilometers away, a 3-day journey by spacecraft. It's so close, yet it feels distant. Neil Armstrong's first footprint on the Moon is still there, untouched, because there's no weather to erase it. It's been decades, yet it remains. Moving further, we see Venus, often referred to as the planet of love and romance. Covered in thick yellow clouds, Venus reflects sunlight, making it the brightest planet in our solar system. It's similar in size to Earth, often called Earth's sister. But beneath those golden clouds lies a nightmare, an immense atmosphere filled with toxic gases, violent storms, and surface temperatures near 500 degrees Celsius. Nothing could survive here. From the outside, it's beautiful. On the inside, it's pure hell. Now we come dangerously close to the sun. Everything around us tells us to go back, but how could anyone resist this magnificent sight? The sun, our light, our life, is 150 million kilometers from Earth. If it were to suddenly stop shining, it would take 8 minutes for us to even notice. It's so massive, it could fit over 1 million Earths inside. Where we are now, the temperature exceeds 10,000 degrees Celsius. But even this star will one day die, and when it does, so will Earth. Now we move on to the red planet, Mars. For centuries, we've searched for signs of life here. More than any other planet, Mars has captured our imagination. It's red, desolate, and lifeless. But one theory suggests that life may have actually begun here and later came to Earth. If this is true, we are all Martians.
As we continue, we encounter even more mysteries waiting to be discovered. Massive computers are being developed to analyze and explore the unknown. Near us, we spot asteroids racing through space at 80,000 kilometers per hour. Most planets were formed by the merging of such space rocks. We are now 680 million kilometers away from home, facing the giant Jupiter, a planet at least 1,000 times larger than Earth. Its famous red spot is a massive storm, 3 times the size of Earth, and it has been raging for over 300 years. Lightning storms roar within it, dwarfing anything we know. Then comes Saturn, our solar system's crowned jewel. Made mostly of gas, it's so light it could float on water. Its iconic rings are made up of billions of ice particles, some as big as houses. We could stay and admire Saturn forever, but we must move on. We now reach Titan, Saturn's largest moon. It has rain, seasons, and rivers, similar to Earth, but instead of water, these rivers carry liquid methane. Titan holds more hydrocarbons than all of Earth's known reserves. In the future, it could provide us with endless energy. Now we are 1.5 billion kilometers from Earth. We encounter Sedna, about 13 billion kilometers away. It's so far from the Sun that it takes 13,000 years to complete one orbit. But there's something else, a man-made object from Earth, the Voyager spacecraft. Now over 16 billion kilometers away, it holds messages in many languages and a map showing our location. Could someone out there receive our message and knock on our door? Right now, we've only taken baby steps in space. There are billions of planets waiting to be discovered. Even reaching the next closest star system, Alpha Centauri, just over 4 light-years away, would take 50,000 years with current technology. At this scale, distance is no longer measured in kilometers, but in light-years, the distance light travels in a year. 1 light-year equals about 10 trillion kilometers. At 20 light-years away, the star Gliese 581 may have planets in the habitable zone. If life exists there, they might be watching our old TV broadcasts from 20 years ago. At 65 light years from Earth, they might even be listening to Hitler's 1940 radio broadcast, the first strong signal Earth ever sent into space. We approach the Seven Sisters, or the Pleiades, a group of stars in the Orion constellation. According to Greek mythology, they were turned into stars to help carry the heavens. We now witness supergiant stars, 600 times larger than our Sun, so large that 600 million Earths could fit inside. Then something strange, a dark cloud, the Orion Nebula, where stars are being born, though slowly. Here we see stars grow and then explode. A supernova rips itself apart, ejecting material into space. At its heart remains a white dwarf, so dense that a teaspoon of its matter weighs tons. In about 6 billion years, our own sun will also die and become a white dwarf. Now we reach a stellar graveyard, 6,000 light years away, and encounter a pulsar, a spinning neutron star only 20 kilometers wide but as heavy as 1 billion tons. It emits powerful radiation. Then we encounter something more terrifying, a black hole. Instead of becoming a white dwarf or pulsar, this dead star has collapsed infinitely. Its gravity is so strong even light can't escape. Inside, time and space cease to exist. The laws of physics break down. No one knows where a black hole leads. Despite traveling trillions of kilometers, we're still within our own Milky Way galaxy. We haven't even left home yet. Now we enter intergalactic space. Each glowing point is a galaxy, as big as ours, with billions of stars and possibly life. We reach Andromeda, 2.5 million light years away. If we send a message from here, it would take 2.5 million years to reach Earth. We go even farther, 2 billion light years from home. We encounter a quasar, one of the brightest, most energetic objects in the universe, brighter than entire galaxies. Quasars make stars look like dust. And now we reach the edge of everything, the farthest light ever to reach Earth, the afterglow of the Big Bang. This is the observable limit of the universe. It is the farthest we can see until we discover more.